topic dependence of photoelectric effect. In previous video we will discuss on the topic photoelectric effect experimentally proved. We proved, we check and we define the photoelectric effect is occur, how it is occur. Then the current pass through the circuit is called photoelectric current, and today we'll discuss on the topic though this photoelectric effect dependence on which things, and we denote photoelectric effect by IP. So let's start. First we see I is equal to Q upon T. In previous class we study I is equal to Q upon T. I is current and Q is a charge and T is a time. So here if photoelectric current is also a current, then we written is, and in first chapter we see charge is equal to Q into NE. So we can write here so photoelectric current is depend on the number of electrons and time, and that intensity of light is also depend on number of electron. So we can write here IP is depend on number of electron and I is equal also depend upon, so IP depend upon I. So from this we can draw a graph between IP and I. So the graph between IP and I is straight line, because if we increase IP, then I is also increased. In above relation we study IP is depend upon number of electron and I is also depend upon number of electrons. So the relation between IP and I is the straight or linear relation, and the graph between is called straight line. And second photoelectric depends upon energy and frequency and wavelength of a photon. So we find the relation between that. Now we find the relation between them. Energy, frequency and wavelength, photon or light. So in this statement we study is that if we increase energy, then photoelectric current is also increased. In this statement, if energy of photon is increased, then kinetic energy of photon is also increased. In above physics class we see according to Einstein equation, we see if we increase energy of photon, then kinetic energy is also increased. So we can write here energy of photon is depend upon kinetic energy of electron. If we increase energy of photon, then kinetic energy is also increased. So we write here the relation between energy, frequency and wavelength is equal to h nu is equal to h upon lambda and c is equal to mu into lambda. So nu is equal to c upon lambda and c is a constant, then the relation is inversely proportional. If we increase the frequency, then lambda decreases. So in energy of photon, frequency is also included, and the frequency of photon is directly proportional to the energy of photon. So if we increase the energy of photon, then frequency is also increased and wavelength is decreases. So photoelectric current is also depend upon energy of photon, wavelength and frequency of photon, and kinetic energy. So we write here, if we increase kinetic energy, then energy also increases, frequency increases and lambda decreases. If we decrease it, E decreases, frequency decreases and lambda increases. So this relations is between energy, frequency and wavelength of photon of light, and the third statement is so we have study here. We have study about here photoelectric effect. So we will discuss also the relation between photoelectric current. What is the effect of energy and frequency of wavelength on photoelectric current. So we discuss if kinetic energy decreases, if kinetic energy increases on the increases of energy. So kinetic increases, then electron moves quickly, rapidly. So time dilation between cathode plate to anode to reach this distance. So time decreases. If electron move fastly, you think if velocity increases, then time decreases, and if time decreases, then current increases. So the relation between energy and IP is directly proportional. If we increase energy, then IP is also increase, because the distance between cathode and anode reaching time decreases. When electron move quickly, then the time between to reach cathode to anode it decreases, so IP increases. So the third is third is potential difference on anode. So if we increase, we draw here the circuit. Here is the vacuum tube. If here is always negative, we change it by the commutator. We can change here the sign. If here is negative and we increase here the positive potential difference by the help of potential divider. So the electron move quickly towards the anode plate, and the time dilation between is decreases and the current increases, so IP is also increases. If we increase here the negative potential, then the electrons repel by the anode, because there is a negative and there is also negative sign, so it repels the electrons towards the cathode, and the time dilation between is also increases and the current is also decreases, so IP is also decreases, because when electron moves inside and there is also electron, then they repel
they repel each other, and kinetic energy of the electrons decreases and time increases, so IP decreases. So this is they are the three statements of the dependence of photoelectric current. So I will tell you, repeat them, all the three. First we see the IP depend upon IN. IP depends on I, means intensity of light is depends upon the photoelectric current. Second is energy of photon is depend upon the IP, because if we increase energy of photon, then IP is also increases. And the third statement is potential difference on anode. If we increase positive potential on anode, means collector plate, if increase positive, then electrons accelerated by positive potential towards the anode plate, and if increase negative, then it repel the electrons, and the charge decreases due to this repulsor, and time increases, so photoelectric current is also decreases. So thanks. If you like this video, then you like and subscribe my channel. Thank you. That's all from my side.